Our universe is vast. It's filled with billions of galaxies, each teeming with stars and planets. Recent discoveries have brought us closer than ever to answering the age-old question of whether we are alone. The discovery of TOI-715b, a super-Earth orbiting a distant star, has sent ripples of excitement through the scientific community. This newfound world, larger and heavier than our own, is a tantalizing glimpse into the diversity of planets beyond our solar system. Could TOI-715b harbor life? What secrets does it hold? Join us as we embark on a journey to uncover the secrets of this fascinating celestial object. TOI-715b, a name that sounds more like a droid from a Star Wars movie than a planet, is located approximately 137 light-years away from Earth in the constellation Pictor. This distance, while vast in human terms, is considered relatively close in astronomical terms. Its discovery, announced in Insert Year of Discovery, was made possible by the Transiting Exoplanet Survey Satellite, TESS. TESS, a space telescope specifically designed to hunt for exoplanets, searches for tiny dips in a star's brightness caused by a planet passing in front of it. TOI-715b orbits a red dwarf star, a type of star smaller and cooler than our Sun. The discovery of TOI-715b orbiting a red dwarf star adds to the growing list of exoplanets found around these stellar objects. TOI-715b is classified as a super-Earth, a term used to describe exoplanets with a mass greater than Earth's but significantly less than that of the ice giants in our solar system, Uranus and Neptune. While the name might conjure images of a lush, Earth-like world, the reality is that we are still in the early stages of understanding the true nature of TOI-715b. Scientists estimate that TOI-715b is approximately 1.5 times the size of Earth and has a mass about 6 times greater. This information provides clues about the planet's density and composition. Is it a rocky world like Earth, or is it a gas-shrouded mini-Neptune? The discovery of TOI-715b is significant because it represents a stepping stone in our quest to find another Earth. In the grand cosmic theater of the universe, where celestial objects take center stage, super-Earths have emerged as a captivating new act. These planetary heavyweights, larger than Earth but smaller than Neptune, have captivated astronomers and ignited our imaginations. Their discovery has challenged our understanding of planetary formation and expanded the possibilities for life beyond our pale blue dot. Super-Earths represent a class of planets that we don't have in our own solar system, making them all the more intriguing. Their existence hints at the incredible diversity of planetary systems scattered across the Milky Way galaxy. The study of super-Earths is crucial to unraveling the mysteries of planetary formation and evolution. By studying these distant worlds, we gain insights into the processes that shaped our own solar system. Beyond our cosmic backyard, the quest for other worlds. The search for exoplanets, planets orbiting stars beyond our Sun, has become one of the most exciting and rapidly evolving fields in astronomy. Driven by an insatiable curiosity to know whether we are alone in the universe, scientists have developed ingenious methods to detect these distant worlds. The discovery of the first exoplanet in 1995 marked a pivotal moment in our understanding of the cosmos. Since that groundbreaking discovery, the number of known exoplanets has skyrocketed, thanks in large part to advances in telescope technology and data analysis techniques. The Kepler Space Telescope, a prolific planet hunter, played a crucial role in this exoplanet revolution. The search for exoplanets is not just about finding other planets. It's about understanding the conditions that give rise to planetary systems. The Goldilocks Zone, a cosmic balancing act. In the cosmic real estate market, the habitable zone, often referred to as the Goldilocks Zone, is prime property. This region around a star is where conditions are just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. Liquid water is considered essential for life as we know it, making planets within the habitable zone particularly enticing targets in the search for extraterrestrial life. The size and temperature of a star determine the location and width of its habitable zone. Smaller, cooler stars have closer-in habitable zones, while larger, hotter stars have habitable zones that extend farther out. Other factors, such as the planet's atmosphere, composition, and the activity of its host star, also play crucial roles in determining whether a planet can support life. Super-Earths and the potential for life. A cosmic gamble. The discovery of super-Earths, particularly those orbiting within the habitable zones of their stars, has fueled speculation about the potential for life beyond Earth. These larger, more massive planets offer intriguing possibilities for hosting life, but they also present unique challenges. Super-Earths have stronger gravitational pull than Earth, which could result in thicker atmospheres and more extreme surface pressures. On the other hand, their larger size and mass could mean that super-Earths are more geologically active than Earth, with more volcanoes and plate tectonics. This activity could be beneficial for life, as it helps to regulate a planet's climate and recycle nutrients. Further observations and analysis are needed to determine the atmospheric composition, surface conditions, and potential for habitability on these intriguing worlds. Enter TOI-715b, a super-Earth that has captured the attention of astronomers and reignited our fascination with the search for life beyond Earth. This exoplanet, located approximately 137 light-years away, orbits a red dwarf star, a type of star smaller and cooler than our Sun. TOI-715b is significantly larger than Earth, with a radius about 1.5 times that of our planet. Its mass is estimated to be about 6 times greater than Earth's. What makes TOI-715b particularly intriguing is its location within the habitable zone of its host star. This means that the planet receives just the right amount of energy from its star to potentially allow liquid water to exist on its surface. Further observations are needed to determine whether TOI-715b has an atmosphere and, if so, what its composition is. Imagine Earth, our home planet, a vibrant blue and green oasis teeming with life. Now, picture TOI-715b, a distant super-Earth shrouded in mystery. How do these two worlds compare? What similarities and differences might they hold? On the surface, Earth and TOI-715b seem like vastly different worlds. Earth, a relatively small, rocky planet orbiting a yellow dwarf star, boasts a diverse biosphere and a temperate climate. TOI-715b, on the other hand, is a larger, more massive planet circling a cool, red dwarf star. Despite their differences, both planets share a crucial characteristic. They reside within the habitable zones of their respective stars. One of the most striking differences between Earth and TOI-715b is their size. Earth, with its diameter of about 7,900 miles, is dwarfed by TOI-715b, which boasts a radius roughly 1.5 times larger. This size difference translates to a significant difference in surface area, with TOI-715b having more than twice the surface area of Earth. Mass plays a crucial role in determining a planet's gravitational pull, its internal structure, and its potential for holding on to an atmosphere. TOI-715b is estimated to be about 6 times more massive than Earth. This increased mass means that TOI-715b has a stronger gravitational pull than Earth. A more massive planet can hold on to a thicker, denser atmosphere, which can have significant implications for the planet's climate and potential for hosting life. Section 3. Atmospheric Mysteries. Unraveling the Secrets of TOI-715. B. Earth's atmosphere, a delicate shroud of nitrogen, oxygen, and trace gases, is essential for life as we know it. But what about TOI-715b? Does it have an atmosphere? And if so, what is it made of? Unfortunately, scientists are still working to determine whether TOI-715b has an atmosphere. Detecting and characterizing the atmospheres of exoplanets is a challenging task, even with the most advanced telescopes. Scientists can use a technique called transmission spectroscopy to study the light that passes through a planet's atmosphere as it transits, or passes in front of, its host star. If TOI-715b does have an atmosphere, its composition will provide valuable clues about the planet's history and its potential for hosting life. Section 4. The Search for Water. A Cosmic Treasure Hunt. Water, the elixir of life, is essential for all known forms of life on Earth. So, it's no surprise that the search for life beyond Earth often begins with the search for water. The fact that TOI-715b resides within the habitable zone of its star is an encouraging sign. This region around a star is where temperatures are just right for liquid water to exist on the surface of a planet, given the right atmospheric conditions. However, being located within the habitable zone does not guarantee the presence of liquid water. Future observations with more powerful telescopes could reveal the presence of clouds, oceans, or even signs of water vapor in the planet's atmosphere. Section 5. The Red Dwarf Dilemma. A Balancing Act for Life. TOI-715b orbits a red dwarf star, a type of star that is smaller, cooler, and much less massive than our Sun. Red dwarfs are the most common type of star in the Milky Way galaxy, making them intriguing targets in the search for exoplanets and life beyond Earth. However, red dwarf stars present both opportunities and challenges for life as we know it. Their smaller size and cooler temperatures mean that their habitable zones are located much closer to the star than the habitable zone around our Sun. This close proximity can be beneficial for life, as it allows planets to receive enough energy from their star to maintain liquid water on their surfaces. However, it also means that planets orbiting red dwarfs are often tidally locked to their stars. Imagine a planet where the sun never sets on one side and never rises on the other. This is the reality for tidally locked planets, and it can create extreme temperature differences between the day side and the night side. On the day side, facing the star, temperatures could soar high enough to boil water, while the night side could plunge into a deep freeze. This extreme temperature gradient could lead to powerful storms and atmospheric circulation patterns. Some scientists believe that life could adapt to these extreme conditions, perhaps evolving to thrive in the twilight zone between the scorching day side and the frigid night side. Whether TOI-715b is tidally locked to its star is still unknown. So, does life exist on TOI-715b? The honest answer is that we don't know yet. The discovery of this super-Earth within the habitable zone of its star is an exciting development, but it's just the first step in a long journey of exploration and discovery. Many factors influence a planet's habitability, and we still have much to learn about TOI-715b. Its size, mass, and location within the habitable zone are all promising signs, but they don't guarantee the presence of life. We need to determine whether TOI-715b has an atmosphere, if so, what it's composed of, and whether it contains water. We also need to learn more about its rotation period, its climate, and its geological activity. The search for life beyond Earth is a challenging but ultimately rewarding endeavor. Each new exoplanet discovery, each tantalizing clue, brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? Imagine trying to spot a firefly flitting around a lighthouse from hundreds of miles away. That's the challenge astronomers face when searching for exoplanets, planets orbiting stars beyond our sun. But just as skilled detectives use ingenuity and technology to solve mysteries, astronomers have developed remarkable methods to unveil the secrets of these distant worlds. Directly observing exoplanets is incredibly difficult. The light from their host stars vastly overpowers the faint glow of these orbiting worlds, making them nearly impossible to see directly with current telescopes. So, astronomers have turned to indirect methods, relying on subtle clues to infer the presence of these hidden planets. These cosmic detectives use a combination of physics, mathematics, and cutting-edge technology to analyze starlight, searching for telltale signs of planetary companions. Two primary methods have revolutionized the hunt for exoplanets: the transit method and the Doppler wobble method. These methods, along with future advancements in telescope technology, are providing us with an unprecedented glimpse into the diversity of planetary systems scattered across the cosmos. Imagine a moth fluttering across the beam of a spotlight. You might not see the moth itself, but you would notice a slight dip in the light's intensity. Astronomers use a similar principle, known as the transit method, to detect exoplanets. When an exoplanet passes directly between its host star and Earth, from our perspective, it blocks a tiny fraction of the star's light. This transit creates a subtle but detectable dip in the star's brightness, signaling the presence of an orbiting planet. The amount of starlight blocked and the duration of the transit provide valuable information about the planet's size and orbital period. Larger planets block more light, and planets orbiting closer to their stars have shorter orbital periods. The transit method, while powerful, has its limitations. It only works if the planet's orbit is aligned edge-on to our line of sight, and it favors the detection of larger planets orbiting closer to their stars, as these produce more noticeable dips in starlight. Imagine a pair of dancers, one much larger than the other, gracefully waltzing around a shared center of gravity. The larger dancer wobbles slightly, influenced by the smaller partner. Astronomers use the Doppler wobble method to detect exoplanets. A star's light shifts to blue when moving towards us and red when moving away. This wobble produces measurable shifts in the star's spectrum. The discovery of TOI-715b, like many exoplanet discoveries in recent years, can be attributed to the tireless work of a remarkable space telescope, the Transiting Exoplanet Survey Satellite, or TESS. TESS, launched in 2018, is on a mission to scour the cosmos for exoplanets, focusing on nearby bright stars. Equipped with 4 wide-field cameras, TESS observes vast swaths of the sky, monitoring the brightness of millions of stars with remarkable precision. TESS uses the transit method, patiently watching for those telltale dips in starlight that betray the presence of orbiting planets. Its wide field view and sensitivity allow it to detect both large and small planets, providing a more complete census of planetary systems in our cosmic neighborhood. The data collected by TESS is a treasure trove for astronomers, revealing not only the presence of exoplanets, but also their sizes, orbital periods, and potential for habitability. While TESS and other current telescopes have revolutionized our understanding of exoplanets, the future holds even greater promise. Astronomers are eagerly anticipating the launch of new, more powerful telescopes that will sharpen our view of these distant worlds. The James Webb Space Telescope, launched in 2021, will use its infrared vision to peer through the atmospheres of exoplanets, revealing their compositions and potential for hosting life. Its unprecedented sensitivity will allow it to study the atmospheres of smaller, potentially habitable planets. Ground-based telescopes are also undergoing significant upgrades. Adaptive optics, which compensate for the blurring effects of Earth's atmosphere, are enabling telescopes to achieve sharper images than ever before. These advancements in telescope technology, combined with ongoing improvements in data analysis techniques, will usher in a new era of exoplanet discovery, providing us with an even richer understanding of the diversity and evolution of planetary systems throughout the cosmos. The discovery of exoplanets has profoundly impacted our understanding of the universe. For centuries, humans have gazed at the stars, wondering if other worlds existed. Now we know our solar system is just one of billions across the cosmos. This realization has shifted our cosmic perspective. The diversity of exoplanets suggests planetary systems are common. This knowledge humbles us while igniting our curiosity to explore further. Perhaps the most profound question driving exoplanet research is whether life exists elsewhere in the universe. The discovery of thousands of exoplanets has fueled speculation and intensified the search for signs of extraterrestrial life. The search itself is a testament to our innate curiosity and our desire to understand our place in the cosmic order. The discovery of even the simplest life forms on another planet would revolutionize our understanding of biology and evolution. It's about answering one of humanity's oldest and most profound questions. Are we alone? As we venture further into the cosmos, searching for signs of life beyond Earth, we must proceed with caution and a sense of responsibility. The discovery of extraterrestrial life would be a momentous occasion, but it's crucial that we avoid contaminating other worlds with Earth-based life or inadvertently harming any life that might exist. Planetary protection, a field dedicated to preventing biological contamination between Earth and other celestial bodies, has become increasingly important as we explore our solar system and beyond. Spacecraft are rigorously sterilized before launch to minimize the risk of carrying Earth-based microbes to other planets or moons. Similarly, protocols are in place to prevent the accidental return of extraterrestrial life to Earth, where it could potentially pose risks to our biosphere. Samples returned from other planets are carefully contained and analyzed to ensure that they do not contain harmful organisms. By adhering to strict planetary protection guidelines, we can explore the cosmos responsibly, preserving the integrity of other worlds while safeguarding our own planet from potential biological threats. The discovery of exoplanets and the search for life beyond Earth inspire a new generation of scientists, engineers, and explorers. The quest to understand the cosmos is a testament to human ingenuity. Exoplanet research pushes the boundaries of science and technology, leading to advancements in telescope design and data analysis. It inspires us to dream big and explore the unknown. TOI-715b stands as a testament to the boundless possibilities of the cosmos. Our solar system is just one tiny corner of a vast and diverse universe. Billions of stars light up the darkness, each a potential sun with its own family of planets. TOI-715b's discovery sparks our imaginations. Could this super-Earth harbor life? Could its atmosphere hold clues to planetary evolution? Or could it be something beyond our comprehension? These questions fuel our desire to explore and unravel the mysteries of the universe. The quest to explore the universe is a journey without end. Each answer we uncover leads to new questions, each discovery to new mysteries. The more we learn about the cosmos, the more we realize how much more there is to know. The discovery of TOI-715b is just one chapter in the ongoing saga of human exploration. As we develop even more powerful telescopes, send probes to other planets and moons, we will undoubtedly uncover new wonders, challenge our assumptions, and rewrite our understanding of the universe. So, let us continue to gaze up at the stars with wonder and curiosity, for the universe is vast, its secrets waiting to be unveiled.